In this section, I want to talk some about the microbiology of water. Water is critically important. It covers approximately 2/3 of the Earth's surface, and it has a ton of biodiversity. I've shown you a picture here of an anglerfish. These are these super weird fishes that live in the very, very deepest parts of the water. But there are lots of life that we may never even learn about. In fact, we actually know more about places like the moon than we do about our own oceans. The other thing to think about when we think about water on the surface of the planet is fresh water versus salt water. When you have organisms that have to live in salt water, they have to be tolerant to those different levels of salt. If they live in fresh water, they don't. And many times you can't go back and forth. So there are some organisms that can, but there are many, many more that cannot. And so you have to understand those totally different habitats. We have warm versus cold water, which would require the organism to adapt to one temperature or the other. And we have deep versus shallow. Organisms that live in the very, very deep ocean have to deal with really high pressure. There's a ton of pressure on those organisms, like physical pressure. So they have evolved mechanisms to keep their cells from collapsing so that they can live in those very deep environments. Water is also absolutely necessary for supporting life. You know that. People will die if they don't drink water, and they'll die relatively quickly. Depending on the time of day, your weight, age, sex, water can range anywhere from 45 to 75% of your body weight. And a healthy individual will lose about 2.5 liters of water per day. And that will be through evaporation, so through sweating, through urination, and even your respiration, your breathing can cause you to lose some water. So you have to replace that. As humans, we tend to replace our water through drinking water. We can also eat moisture-rich foods. We can consume other beverages as well, but water is generally the best. And we use water in our bodies to help us remove waste, to keep our joints lubricated, to help us digest food, to regulate our body temperature. It's the main component of blood, so on and so on and so on. The stat that I usually hear is something like you can survive 3 minutes without air, 3 days without water, and 3 weeks without food. So you can't go very long without having water. The challenge is that even though we require water, there are many places in the world where people living there don't have access to clean water. And often that's because people bathe and drink from the same water source. They don't have indoor plumbing, they don't have really strong sanitation infrastructure. And what that can lead to is fecal contamination of the water. So it's not necessarily that they're defecating in the water, but as they bathe, there could be feces that gets into the water. Sometimes in certain areas, people also have to share water with animals. And animals, they really don't have any care in the world about what they do. And so that can lead to really high levels of contamination as well. And to just kind of show you some of the effects of contaminated water, the Ganges River in India is one of their major water sources. Nearly 400 million people live near this river. And unfortunately, it is extremely polluted with things like sewage, industrial waste, and even religious offerings. And in India, it's thought that 80% of illness and 1/3 of deaths are caused by waterborne disease. So when people don't have access to clean water, there are really significant consequences. So on the river, it's estimated that there are like 200 million liters of raw sewage being dumped daily. And that leads to levels of fecal bacteria of 100 million fecal bacteria in 100 milliliters of water. We can scale it up. If you picture a liter of water, that would be about like 16 ounces or so. So like just a regular sized water bottle. Just picture a regular sized water bottle or soda bottle that you would buy from a vending machine. In that, there would be about 1 billion fecal bacteria in that 1 liter bottle. The level that is considered safe for bathing is 500 fecal bacteria per 100 milliliters, or 5,000 per liter. And so what we're really looking at is that it leads to contamination in the river that is 200,000 times above the level that's considered safe for bathing. And bathing standards are different from drinking standards. Drinking standards are even lower. Other issues with the Ganges are that sometimes people put cremains or cremated human remains into the water, and sometimes whole corpses, including holy men, pregnant women, lepers. At the time that they had pox patients, poor people who couldn't afford a burial or cremation, or small children. So not only fecal contamination, but contamination from decomposing corpses. And this water is used for bathing, washing dishes, and brushing teeth. And so you can see people here along the banks of the river. And during COVID, this headline came out: India's holiest river is swollen with COVID victims, because people didn't know what to do with the bodies, and so they put them in the river. Again, this is just to highlight how water can be contaminated, how high the contamination levels can get, and how important it is to do the best we can to keep water from being contaminated. The World Health Organization estimates that worldwide about 1.8 million people die every year from an infection they got from contaminated water. And about 88% of those are attributed to poor sanitation. And by poor sanitation, we almost always mean fecal bacteria in the water. So while many infections do result from drinking contaminated water, swimming and bathing are not always safe either. And so we're going to start with protozoan infections. And the one that many of you have probably heard of is Naegleria fowleri. Sometimes they call it the brain-eating amoeba. It's found in warm, fresh water, which we have lots of in the US. And what it does is, as a person is swimming in contaminated water, it enters the central nervous system by going up the nose. There, once in the nose, it follows the olfactory nerves, so the nerves that go from your brain to your nose. It follows them back up into your brain and actually begins to consume the nervous tissue. This infection is fatal in over 95% of cases. There have only been a handful of patients who have survived. One of them had a weaker strain of the parasite. It wasn't like as strong. A couple of them were children, and the treatment they do is they basically induce a coma. They lower the body temperature and they pump the patient full of drugs to kill the amoeba. One child that survived had significant brain damage, but a couple that survived relatively normal so far developmentally. Again, you can see that it causes, these are like hemorrhages and focal points of tissue destruction in the brain, and then this is what the amoeba looks like under an electron microscope. So we do have this infection. It's been diagnosed in all of these states here. As you might imagine, states that are warmer during longer periods of time, like Texas and Florida, have higher rates of this infection. Another protozoan infection that you can get from drinking contaminated water is Giardia. I think we've talked a little bit about Giardia before, but it's, again, found in untreated water, found especially in ponds, including those that are made by beavers. So beavers will cut down trees and kind of stop up rivers and streams, and they can form little ponds. And this bacteria is often found in the GI tract of those animals. So if you drink untreated water, it can get into your GI tract. When patients have a Giardia infection, they have diarrhea, cramping, and gas. And the parasite actually can kill the cells in the intestine. It's one of the most common pathogenic parasitic infections in the world, and they estimate 1.1 million cases per year in the US. It forms cysts that can survive in cold water, so even if you're hiking during the winter and you're drinking from what you think is a very cold lake or stream or pond, the cysts, when they get inside of you, can basically revive themselves and cause disease. And so this is what Giardia looks like. I always think it looks like it's smiling at you while it makes you feel very, very uncomfortable. During the earliest part of the course, we did talk a little bit about schistosomiasis, which you can also get from the water. This is not from drinking. This is from swimming or bathing. The larval form burrows into the skin and then transmits itself through the rest of the body. So that's pretty dangerous. And then it can go into places like the intestines, the bladder, the liver, and cause tissue damage in those areas. And we also talked a little bit about these guinea worms. Again, these are from drinking. If you drink unfiltered water that has the aquatic arthropods in it, you can acquire the infection. And what we have is that the female worm will come to the surface of the skin, and you'll see a big blister with the worm sticking out as she's like releasing her larva. So this is one of these infections that people are working on trying to eliminate from the planet. Contaminated water can, of course, give lots of bacterial infections as well. We've talked about plenty of them: cholera, E. coli, Shigella, Salmonella. Anything that has feces in it, you're going to have some of these fecal bacteria in there. But what people sometimes don't know is that you can also get botulism from the water. Clostridium botulinum is the bacteria that causes botulism. And this can happen in a couple of different ways. It can either be ingested or it can get into a wound. So if the bacteria gets into a wound that you have while you're swimming, or if you swallow some water, the bacteria can get into your GI tract. And what botulism does is it produces this toxin that causes you to be paralyzed. And when that gets to your respiratory tract and you can't breathe anymore, that can be fatal. You can also get bacterial or fungal infections from swimming in the ear. They'll call it swimmer's ear. There are a couple of bacteria that are pretty highly associated with it, but there are lots of bacteria that can cause it. So any number of bacterial or fungal pathogens. And again, it's characterized, as you can see in these images right here, really significant swelling of the ear canal. Depending on what organism it is, and depending on how pathogenic that organism is, you can sometimes have really significant tissue destruction where people can lose their whole external ear, and the infection can spread even more. So it's important to get something like this treated. And then what you're seeing in this image over here on the bottom right, these are actually like fungal structures growing inside of the patient's ear. So you can see, they call these like stalks. These are reproductive structures. So the fungus can release its spores that are found up here at the top and continue to spread. There are some viral infections you can get from contaminated water. Polio is one of the most well-known. Polio, we talked about again, is one of those diseases that has almost been eradicated, but it is transmitted through the fecal-oral route. So if somebody that has polio defecates into a water supply, the virus is going to be in that water supply. And if someone drinks it, then they have the potential to get polio. So this is a bacterium that normally, again, is transmitted through that fecal-oral route. But in some patients, it can cause central nervous system disease. And you can see patients who have paralysis caused by polio. We also have hepatitis A, which we discussed a little bit in the chapter on food, which can also be found in contaminated water. The liver, when that gets inflamed, that's the most dangerous complication. But otherwise, most patients who get hepatitis, it's going to be, a little bit of diarrhea and discomfort, and then that's about it. So how do you prevent getting infection from one of these waterborne illnesses? Well, many, if not most, are transmitted through fecally contaminated water. So whenever possible, you want to make sure that you're drinking treated water. If you're camping or hiking, you should be boiling your water, or have some sort of filtration device to filter the water you drink. You should never drink untreated water. We in the U.S. don't dispose our waste in the same place that we drink from. So again, boiling water, filtering water. There will be times where city water supplies can be contaminated and an entire city can be on a boil order. When I was a kid, we lived in Atwater, and there was pigeons that got into the water supply or something like that. And so we had to boil our water for a few days because of the contamination from the pigeons. So it happens. And, on a small scale, it's pretty easy to protect yourself. But, to bring in that infrastructure of sanitation to provide everybody with clean drinking water is really difficult. And that's why there are still places in the world that don't have access to clean drinking water.